This video looks at open and closed systems, and this is some language and kind of discussion that we have to go through before we actually talk about conservation of energy, because it informs how we talk about conservation of energy. So looking at that, first thing we're going to talk about with systems, defining what a system is, so then we can talk about what kind of systems are open and what kind of systems are closed. So a system is a collection of elements, and by elements we mean objects or forces, well, usually things that we can physically interact with. So it might be waves, it might be cars, it might be chemicals, it can be any sort of collection of elements as long as those are physically interactable with. And it can be made of as many or as few of those elements as desired. So systems can be continuously defined and redefined as long as we know what's in that system. So for example, if you're dropping an apple, you might say the apple is the system. Or you might say the apple and the earth is the system. Or you might say the apple and the earth and the hand that dropped it is the system. So you can see that you can talk about whatever you want to be a part of it. It's just, whatever you want to be a part of it, you just need to make sure you've clearly defined this is the system, this other stuff is not the system. So as an example, like I said, you might have a car and the road might be a system, and then you could talk about how the car loses energy to the road, like the road heats up, the tires heat up, stuff like that. You could have like a roller coaster, a cart, and the earth. And then you can talk about the energy changes that happen within this system. It can be really literally whatever you want, as long as you know what's inside and what's outside the system. And so the surroundings include everything else. So whatever's not in your system, that's the surroundings. So everything in the entire universe that you didn't say was part of your system is part of the surroundings. So now that we've defined systems, let's talk about the two kinds that we can have. First is a closed system, and this type of system does not interact with its surroundings. So in other words, energy cannot go into or out of the system. It's trapped inside, and it excludes energy from outside. So as a result, the equation that we talk about for this is that the change in energy of the system, the total change in energy of the system, has to equal 0. And that's going to equal, change, sorry, that's missing a delta there, so let me fix that. The total change in energy of the system. So that will equal the change in energy system 1 plus the change in energy system 2 plus the change in energy system 3, etc. So if you add up all the changes, they have to equal 0, because no energy can go in, no energy can go out. And that means if we're going to conserve energy, you can't have a total change. An open system, conversely, does interact with its surroundings. So energy can go into the system or out of the system. So the equation that we're going to have there is that the total change in energy equals the heat or the work done on the system, the heat added or the work done. So again, that'll just be the change in energy system 1 plus the change in energy system 2 plus the change in energy system 3, etc. So in both cases, the energy is conserved. It's just if you're closed, all the changes have to balance out within your system. If you're open, you can kind of spill over. You can let some energy leave, or you can bring some energy in. But if we redefine our system larger to include whatever system from our surroundings is gaining or losing energy, we can close off the system, we can show that it's conserved. This means for the entire universe, if that was our system, then that would be a closed system because by definition in physics, there's nothing outside of the universe. So that's kind of a summary of the idea of open and closed systems, and we'll talk more about them when we get to conservation of energy in the next video.